So just to make it so this video isn't very short, I will redo this. Hopefully it'll give me time to do a better explanation. And now I have these new tools since I'm using Screencastify. All right, so let's see what we have here. So we're trying to say that these two lines are parallel. So what the first thing we have to say is that those two lines are parallel because it's our given. The next is like, what makes it so the corresponding sides are congruent? So when we're talking about corresponding congruent sides, we're essentially talking about this side being congruent to this side. So we're looking at angle A or BAC, or we can call it even B or DAC. And basically, angle A and angle B is what we're looking at, these two corresponding sides. So if we're looking at that, we're going to look at angles, angle A and angle D, A and D, and we're also looking at angle C and angle E. And that's another one over here. Let me use a different color to represent that they're different angles. Oh, my color options. My color options disappeared. There we go. That was weird. All right. This angle and this angle are congruent. And there's this idea that if we had two parallel lines and we cut them by a transversal, then we have the corresponding sides. All right. So moving on from here, we're going to say that D and A, and we're going to say that E and C. So D and A and C and E. So those are congruent. Next, we're going to say that this angle is similar to this angle because of the angle-angle similarity principle. Let me clear the board. So this has two angles that are like this. So angle-angle similarity tells us that those two angles are similar. So these triangles, this triangle here, this ABC is similar to this DBE. From there, we can use proportionality. So the idea that if two triangles are similar, then they must be proportional to each other. And we kind of learned that in the previous module. So that means that we have this. So something like DB is proportional to AB. So DB is proportional to BE. And we can say that CB, so notice how the big one's on top. So we're doing the big divided by the small. Let me kind of do this. So we're doing this big line divided by this smaller line, and then we're going to do this big line divided by this smaller line. So that's what we're doing right here. We're going to bring this over, bring it over here, clear the board. Next, it's like segment addition. Well, we can say that DB plus AD is equal to all of this AB. So we're basically just adding this plus this to make this entire thing right here. So that's where we're doing all of our big ones being there. And then substitution. Well, to substitute, we can use this. Instead of writing AB right here, we're going to write AD plus BD. So that's why we have the same fraction from up here. Oh, I forgot I can do this from up here and do it. I was trying to think of a tool I could use, and I was like, oh, wait, I can do this. So we're combining these two ideas right here to do this. Next, they're kind of splitting the idea where these two can cancel out. So you can split the numerator into two different things. This is the thing I complained about at the end of the last video, is that they're skipping the step where we do this. And yes, this is supposed to be a D. I just wrote it terribly. So this turns into this. They just kind of skip and go, oh, we can just cross those out. And from here, if we take away 1 from both sides, that's why they're doing the subtraction property, that's how we get this final idea here. So basically what we're doing is we're saying that AD here to here divided by these two is equal to this half is equal to this divided by this. So these two divided by each other can go into these two divided by each other. So they're proving that because these two triangles are similar, you can say that these two sides are proportional to these two sides. It's actually one side, but we're just kind of breaking it in half. All right, so from here, let's go on to the next slide. So we're doing if-then statement here. So we're just saying that if P then Q, that means if Q then P. This is known as a converse argument. So if P is true, then Q has to be true. And if we're using the converse, that's saying that, well, that means if Q is true, then P has to be true. Proving T is true does not imply S is true. Oh, okay. It's saying that if you prove this, it doesn't mean that this is true. So sometimes this works. These are known as if and only if statements. P can only be true if Q is true. That's usually how we do it in math. In math, we usually say that if one thing's true, then the other thing has to be true, and vice versa. Sometimes the vice versa doesn't work. Like, for example, this is more in the logic sense, but like the idea that a thumb is, or I'm sorry, a thumb is a finger, but that doesn't mean that a finger is a thumb automatically. This is not an if and only if statement because not thumbs are fingers, but not all fingers are thumbs. In math, we usually deal with if and only if statements, so it shouldn't be a problem. All right, so let's check this out. So let's do some Geogebra. All right, so here in Geogebra, what we're going to do here is measure AD and BD. AD, AD, and BD. So let's go to our measuring tools. Go here, distance, AD, and then we're going to do DB. Measure those. All right, and now what is the ratio? So we're going to find out what this ratio is. So we're going to divide this out. And I'm wondering if these drawing tools is a lot better than my drawing tools from before. Let's see. It should be, because I don't think they're connected. Yes, they are. I just need to pick better colors. 1.857, and I'm going to do the big one on top. So let's grab a calculator and calculate this out. So one thing that I've never really shown you guys before is you can just use a calculator here. So 1.5, we're going to divide that. So you can see I hit that little division sign. 1.825, and we get about 1.17. Make sure you're showing your work. So in here, make sure you use your equation editor. It's a fraction, 3.125 over, was it 1 point? Yeah, 1.875. We're going to say that equals that. So right there, we get that solved. Measure AC, locate the point at which this should be. So we're going to try to figure out another point X. So where E. So we're going to try to figure out where an E would be. So one of the reasons why they're being nice to us by having this here is it's really hard to calculate distance diagonally. So they're like, we're going to leave it like this so you don't have to Pythagorean theorem this. So if we look here, the distance here is 13 because it's 14 take away 1. That's 13. So 14 take away 1 equals 13. 13. And now we're going to try to figure out where this is. So this proportionality thing, we're going to take this number and we're going to divide it out. Because what's happening here, I should have thought this out better. We're switching this. So we're going to, so this is a small. So it's, I did big divided by small equals, let's say the dilation factor. This will end up being the small times d equals the big side. But I don't want that. I want to take the big side and figure out the small side. So I'm going to divide. So I'm going to take the big side and divide it by my r, or my d, my dilation factor. So my big side is 13, and I'm going to divide that by 1.7. 1.71. Let's see what that is by using this calculator right here. So 13 divided by 1.71, hit enter, and it's about 7.6. So we're going to kind of approximate this. So that should be about 8.6. One thing you can do to kind of cheat the system a little bit is we know it has to be on the 1. So the y value is 1. So what you can do to kind of make it go where it's supposed to go into this and just change the value into what it's supposed to be. So that's going to be 7.6. So our x value is 7.6 and our y value is a 1. So now it's a little more accurate. And the reason why I did it this way is I wanted to go from the corner to there. Because this was from the corner to here. If you would have done it from the other corner, it would have thrown it off a little bit. So let's do that. So now we're going to figure out if this works. And the only way to figure out if it works is by finding the angle. To place point E. Yeah, we already did that. Passing through the point. So now we have to make that and record the slopes. So they want us to record the slopes to see if they're parallel. Okay, so let's go to our creation tool. We're going to create a segment from here to here. And then we want to find the slope. So we go to our measuring tool. We're going to measure the slope. Boom, boom. And I'm off by like a little bit. I wonder what happened here. I thought I did this right. The slope is negative 0.4. The slope here is that. They look parallel. I don't see why the slope wouldn't be correct. Did I do that? Yeah, I should do this right. It's 13. Now I'm starting to doubt myself, guys. Let's see here. A to measuring tools, not area. A to C. Yeah, that's 13. I don't know why I doubted myself on that one. And then if I do my slope, I guess they're off by like a little bit. There's probably some round off error, but for the most part, it should be right. Let's see here. Oh, I see where it went wrong. It was supposed to be AB. I didn't measure AB. What did I measure? EB. Find the ratio. So the ratio from A to B is that. And then here, my ratio. So the way I went about this, guys, is wrong because for some reason I thought I measured AB. I didn't measure AB. I measured DB. So this is the ratio. This is basically the idea of. Ugh, they made this nasty for you guys. I'm sorry. I thought they would ask you in a useful way, but that's assuming a lot from Edmentum. Essentially, what they're doing is they're saying that the bigger one. I'll show you guys how to do this with fractions. I don't like how they did it. I'm actually going to do this a better way for you guys overall. Give me a second while I recalculate this. I don't want you guys following this direction because they're really doing this in a mean way that's not useful for your guys' learning. Um, don't find the distance between DA. Using ratios, I think with geometry is a little hard at this point, so I'm going to redo part A for you guys. I feel sometimes that whoever made the Edmentum already knew everything and didn't know how to teach it to students. So what I'm going to do here is I'm going to measure the big side, that's 5, and then I'm going to measure the small side, which is 1.875. So this is essentially retaking this idea here. Doing this, making that 5. And now what I'm going to do is I'm going to do 5 divided by 1.8. Really, the backspace doesn't work. Calculator. We get about 0.533. So I'm doing the big divided by the small, kind of. And then what I'm going to do here is I'm going to do what I should have done before. And now I'm going to do the ratio. And clear that out. 13 divided by 0.53333. Get about 24. It doesn't make sense. Big divided by small, we got that. Mm-hmm. We do big divided by small. I don't trust this calculator anymore. There we go. I don't know what's up with the calculator, guys, because I was like, this doesn't make any sense. What did I do? Might have to check the rewind and find out what I did, because now it's giving me the right answer. I could have sworn I entered it right. I don't trust this calculator. Don't use the Edmentum calculator apparently, because apparently that calculator is terrible. Or they, yeah, I don't trust that calculator anymore. I'm sorry. So let's go back and fix. So to kind of make this simpler, I'm just going to round off a little bit. I'll fix that number right now. Right now, and you have a lot to fix here. And I should have realized that too. It should have come out to a fraction. All right, got that. Let's delete this. Let's figure this out by not using the Edmentum calculator because I don't trust it anymore. So I get about 4.87. So I'm going to do, this is going to be about 4.87. Again, I'm pretty sure I might have done a mistake there too, but just to kind of not risk it, I'm just going to go here. So I need to make that point E. That point E should be somewhere on this line. And I'm going to adjust this point here. Ugh, give me a second. I'm going to make a random point E, and then I'm going to adjust that point E. Fix this. I know the Y value has to be 1, so I'm going to highlight all this and replace it with the number 1. And replace this, and it's 4.87. So there we go. So it's kind of similar to where it was before. I honestly don't remember my numbers, but this should be a lot more accurate. Now let's take our slope. So let's calculate our slopes here. Slope of this line, slope of this line. This is a lot better. I still think there's some round off error, but it's a lot closer than what it was before. Blame it on what you will, but I feel I'm more comfortable with this. So record the measurement of the slope. So let's do this. So I'm going to say M, because usually the symbol for slope is M. Subscript, we're talking about line. What lines are we talking about? Line ED or DE. So that slope of this line is going to be equal to over DE is negative 0.546. And because I'm lazy, copy this over, paste it here, and now we're going to talk about a different line, and that line is BC, and that slope is negative 0.4. There we go. Creative way of just getting that negative 0.4 there. All right. What can you say based off the slopes? They are close to be parallel. There might be some round off error. And I keep forgetting to make sure you guys are submitting these. The reason why I start submitting them now and I never used to do it before is after this one, I'm going to start doing it through the student's account so you can see it the same way. So I'm going to give myself a 3. I had a hard time understanding how to use the ratio. And that's true. Like, I didn't do it the way they wanted me to do it. They wanted me to do it some weird way. So if you look here, they're doing it like this. And then in order to figure out the ratio, they're doing it really weird. They're doing it as x and then the long side minus x. And it's really weird when we can basically just do it as the big one divided by a small one. So ratios are good to use, but I feel like they're making it way more complicated than it has to be. All right, so let's go into this. So we're just saying that they're proportional. So again, we're saying this line is proportional to this line, so this line is proportional to that line. That's a great lesson. We already proved that using the proof, so I don't know why they wanted us to do it with a unit activity. That made it quite harder, to be honest. Doing ratios is kind of hard to do when we're using a whole line and not a part of a line. All right, so let's get this proof down. So first, we have to state our givens. So state our given. That was nice of them to put it just right there. Let's work off this picture. So then they want to use property of equality. So if we're using property of equality, one thing we can do, and I do this a lot when it comes to any type of algebra problem, is this idea if you ever have a fraction equal to a fraction, you can just multiply. You kind of use this little, they call it a butterfly. I still don't see it. I just do cross multiplication. Cross multiplication is when you have a fraction equal to another fraction. So I have AD times EB. So AD times EB. That's not what they're referring to. They're referring to just flipping it. Property of, oh, they're doing AB, DB. What? Oh, they're just replacing the lines again. It feels like we're doing that same proof again. I don't know why we're doing this proof again, but all right. Let's do the same proof again. So now we're going to say that those two, we're going to add those two up. So we're going to add these up. That is property of addition. I don't know what you want me to do here. Addition, property of equality. Oh, we're doing this backwards. We're doing the same proof just backwards now. So now we're adding the 1. I don't know why. And then in order to do that, we have to do this thing where we're turning this 1 into a dB over dB, and we're turning this one into an EB over EB. So again, even when they're doing it backwards, they're skipping the steps. So the first one is the first one, literally the first number 1 is dB over dB. The second one, the second number 1 is EB over EB, and then that allows us to do the fraction. So they're literally doing the same thing just backwards now. And I don't think that necessarily proves anything, because in math, usually we don't have proofs unless the converse is true. So then we're going to add those segments together, and those segments create this. We're going to use this. See, I don't understand why they skip this part, the dB over dB and the EB over EB, but then they're like, oh, we can't just change this to an AB. We have to show this. So I feel like Edmentum kind of picks and chooses what it wants to get rid of. So the reflective property. The reflective property usually involves angles being the same. So for example, angle ABE, or I'm sorry, ABC is equal to DBE. So basically they're just saying that this angle, this is actually kind of interesting. This is probably the less obvious proofs. I mean, it's still kind of obvious saying this, because this angle is itself. So it's just saying angle B is equal to angle B. So this is similar because of side, angle, side similarity. They're proportional. So we're doing side, angle, side similarity. So this small triangle here is similar to this bigger angle overall. And then from there, we can say that corresponding similar angles are congruent. So let's talk about this angle and this angle D over here. So angle A and angle D. And then from there, we can say that these lines are parallel because the angles are parallel. So this angle is equal to that angle, which means they have to be parallel. So it's a long I don't know what Edmentum is trying to have us prove from there. And their proof methods are always very difficult to understand too, because they skip steps. So it's very interesting. So now we're going to use similarity of triangles to kind of finish off the Pythagorean theorem. Okay, so let's take a look at what they want us to do in this next problem. So proving Pythagorean theorem of similar triangles. So now we're going to be proving similar triangles, which I find kind of weird because we just used a similar triangle proof, and now they're saying we're going to prove the similar triangle proof. So we're using proofs. Edmentum has a weird order of doing things. All right. So, what is the measurement of this angle? So let's go to here and we're going to say measurement of angle ABC. Angle ABC. And remember, we want to go counterclockwise. So they actually did it in the right order. Sometimes I've seen that Edmentum will do it in the opposite order. So we're going to go A, B, C. So that's a right angle. So we have uh, do the equation editor, get this little angle symbol right here. I'm going to say angle ABC is 90, get the little degree symbol, degrees, making triangle ABC a, they have the right symbol? Oh, well, they have a perpendicular symbol. I thought they would have the right symbol. Uh, right triangle. Oh, it's a right triangle. All right, cool. So now find a place place a point D along there. So they just want us to make another point D. So use coordinate algebra, finding the and record the coordinates of B that satisfy the requirements. Okay, so we're just trying to find a point D that makes this the altitude. Um, Honestly, the easiest way to do the altitude is you want it to be perfectly perpendicular, going straight up. So they want you to do the algebra, but they haven't taught you the algebra in a while. So what I recommend is doing a perpendicular line. So you're going to pick this line and you want it to be the altitude of the triangle. The highest point would be this B, so it kind of snaps in here. So just make that there. Boom. And you want to make a point D. So what you're going to do here is you're going to want to click right here. No matter what happens now, you can't really move this line out of the way, and you can't move this E. So that E is perfectly there. So now what this is going to do is explain your answer. And what I'm going to do is I'm going to find that point. So that point, you can click here, go to these three little dots, go to algebra, and your point, if you're looking at point E would be 9.6. So what I'm going to do here is say, I use the perpendicular line tool to find the altitude. Selected the point where they touched, making point D 9.6 comma 0. 9.6 comma 0. You can submit that, and they're saying like, oh, it's horizontal. Point D is a. They don't even do a good job of explaining it. They're just like, oh, I use the vertical line. Okay, that doesn't really help. Is there a vertical line tool here? There's not even a vertical line tool here. Come on now. Oh, I guess what they did is they're like, oh, well, if this is 9.6, then this has to be 9.6. I guess. I like my method better, to be honest. All right, so now what we're going to do is we're going to fill in all of these sides. So we're going to do the hypotenuse of triangle ABC, and we're also going to have another side triangle, side of ABC. Come on, Edmentum. Okay, never mind. Okay, they have them here. Short leg, long leg. Why are they repeating? I think what they meant to do was they meant to have three different sides. Oh, these sides are repeating, these aren't. Okay, okay. I was about to get really mad there. So these should all correspond. These correspond with these, and then these are two completely different angles. Okay, there we go. I was about to get very mad at Edmentum. So let's just measure all the sides just to make this easier. So I'm going to go to my measuring tools, go to side, A to C. I'm going to go from this to this. I'm going to go from here to here, and then here to here, and then the last one. And the reason why I like clicking the dots instead of clicking the actual line is it tells me what it is. So if I'm doing AC, all of my AC should be 15. I'm going to do BC. BC, if I look at it, oh, I have it as CB here. It doesn't matter. BC, CB, same side. 9, 9, and then AB. AB is 12, so 12, 12, and then now AB, which is 12, and BD. So there are going to be some overlaps. The reason being is this AB. Notice how it's the hypotenuse of this triangle here, but it's the long side of the overall triangle. BD and BD. So BD, where's BD? BD, where are you? Oh, mine says E. So instead of D, we're going to have this E. I don't know why it's D. Oh, I do have a D here. I just didn't show it, apparently. Let's see if I can delete it and show this. Show this. Why isn't this showing? Yeah, show the object. Okay. They're still calling it E for some reason. Okay. So E is going to take the place of D when we're talking about this. So BE. So BE is 5.4. 5.4. And notice how BE is the shorter side of this triangle, but it's going to be the longer side of this other triangle over here. So that's going to be over here. See how it says long side? So 5.4. And now we want to do AD, which is AE in my triangle for some reason. AE, that's. Did I not do AE? I didn't measure AE. Huh. AE 9.6. 9.6. And then DC is our last one. DC is EC, so 5.4. 5.4. 7.2. I don't know what I did here. 7.2. BC. Oh, I see. I accidentally thought it was the same one. Okay. So CE. CE is 5.4. For BE. BE is 7.2. Okay. And BC. BC is 9. 9. So a lot of overlapping there, guys. Luckily, The reason why they had you do it 3 times is so it's nice and easy to do the hypotenuses over the hypotenuses. So if I do this, make sure you use your little fraction tool. We're going to do 15 over 12. Going to do the next fraction tool. We're going to do 9 over 5.4. 9 over 5.4. And we're going to do 12 over 9.6. So let's do this. We're going to do 12 over 9.6. Now, one thing they don't mention for you to do is they never really said plug it into a calculator. And that's where that's a giant flaw in their logic is if you do it over a calculator, you get 1.259 divided by 5.4. That should have been 1.25. We'll get back to that one. Yeah, so what did I do here? BD, 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 7. All right. Apparently, I just measured the wrong one last time. Uh, duh, duh, duh. Okay, so they're all 1.25. Now, if we do it this way, 9, yeah, it's 9 because it's a smaller triangle. So we're going to do that. And then we're going to do 9 divided by. What they should have instructed was to actually divide it out, which would have been more useful. So I'm going to do that for this next one. I kind of realized it a little too late. I'm like, what's the point of this? And I was like, oh, they totally forgot to tell us to divide it out. You can tell whoever made this lesson was totally a math person and they didn't take into account people who would understand the logic behind this. So you can see that all of them are. So what's happening here is essentially that if you take a perpendicular line, you're making two similar triangles, one small similar triangle and another similar triangle. So all the sides are proportional. So I don't think they want us to really say that they're similar yet. Yep, I had a feeling here. Because both of these are right triangles, identify another pair of congruent angles here. So if this is a right triangle, what's another pair of triangles? So we're going to say angle ADB and angle CDB. So angle, so we're going to say angles, we're going to say angle ADB, ADB, and angle CDB, CDB, CBDC. I'm trying to make it like small angle, right angle, big angle. So I'm going to do small angle, right angle, big angle. So that's why I did it this way. And actually, I wrote these backwards. There we go. Wrote this backwards too. Oh my gosh, I am off today. I am sorry, guys. And those angles are both right angles. How do these observations relate? Identify. How can they relate to the bigger triangle? How do they relate to the bigger triangle to each other? Since the sides are proportional. And I'm probably going to answer this early too. I even waited to say it too. So inside the proportional, and we and have a congruent triangle. So since one of the angles is equal to the other one, the all all three triangles are similar. Oh, yeah, it actually did do it. Well, they're doing it by angle similarity, but they're really stretching it out. What's the ratio of these? What's the ratio of the hypotenuse? We already did that. We literally already did this. Are we really doing this again? Guess we're doing it again. All right. So ABC, and then ADB. Oh, I guess I didn't get ahead. I guess Edmentum wasn't going crazy. They did want us to do this later on, but oh well. And then this one was 1.67, 1.67, Now this one we haven't done yet. So this one we're gonna have to do it as 12 over 9. So 12 divided by 9, 1.3333. 1.33. And just to make sure, we know where they're going with this, but let's just type it in. And 1.333. I just wanted to make sure I could trust that calculator after seeing that I couldn't trust the other calculator. So what can you conclude about this? Never mind. Apparently we couldn't control about this. All three triangles are similar to each other. So because all the sides are uh, proportional by side, similarity. Where's the similarity button? Oh, shift and then the thing. Side, similarity. Notice how it looks like the congruent sign, except it just doesn't have the equal. It's just a tilde. Um, I didn't know where Edmentum was going with this. Here's the thing is Edmentum really wants you to kind of fall through it on your own, but they're very abstract ideas here. Like you can't really know that all of them are proportional, so they're all similar, unless you already know that that's the definition of similarity, which we kind of gone over, but I feel they kind of push the envelope on comprehension. All right, based on your observations of less activity, you can say this. So all of these are paired. So this triangle is similar to this triangle, and this triangle is similar to the biggest triangle, and this small triangle is similar to the biggest triangle. And so all of these are similar to each other. So here, what they're going to do is they're going to construct a perpendicular triangle, and then they're going to say that A, B, D is bigger than A. And then all right, so I really wish they would show the diagrams for all this. So they're going to construct a line. I like how they kind of do this and they're like, oh, figure it out. Then they do this. They construct a line that's perpendicular. Then they're saying that it's by reflective property. This is reflective, is congruent to itself. So then they're saying that these two are congruent. So this thing is congruent to this one because of angle similarity. And because of that, you can use proportionality. And using proportionality will help you kind of figure out that you can cross multiply here. So they're saying that BC, so BC over DC, so DC would be this, I forgot to write D right here, and that's equal to AC. So AC, the hypotenuse, over the BC. So BC would be this side right here. And that's going to help us cross multiply. So, and from that point, we can just cross multiply again for this. So in other words, we end up getting this thing where it's like this squared and then this squared. And they're going to connect this to the Pythagorean theorem, which I feel they're like doing a stretch here. But keep in mind, proofs are part of the mastery test, so you do want to do that. So now you have these two. So you have this is equal to proportions, that's equal to proportions. You can add them together. So you're adding this AC and AD. And from there, they're telling you can factor out. You're taking out this AC, pulling it out. And then because you factored out, you can add these and you get this A squared. So they're really pushing it as far as the proof on why the Pythagorean theorem works here. If you guys need help understanding this, I completely understand. You can always make an appointment with me. Let's take a look here. And as always, you can do the guided notes, kind of walk yourself through it. It's really good because you can fill it out right here and kind of get a feel for the proof yourself. And then you can always write down what you think here. All right, so hopefully I didn't blow through that too fast, guys, but these are your main ideas here. Write these down and take your test. All right. So hopefully that'll help you guys get through this.